Albita, are you there?
Okay. You are crazy, Mr. Levin, tells Samuel. He has to be Samuel. Samuel.
Uh-huh.
He has to be on mission control with me. Benjamin said to the Hubble Middle School librarian. Librarian.
Uh-huh. Okay.
Mr. Levin turned around in his seat. He was almost like a second sponsor of Mark, with a why he was also on the field trip. Heck helped set up a makerspace with a kinds of tools and materials in the back of the media center for the kids to work on their projects. It's a small decision, Mr. Levin answered.
Okay, good. So, what happened here? What was the main idea?
Ok, pueden ver mi pantalla, está el ejercicio de problema número 1.
De los terrenos.
Sí.
Sí, eso.
Bueno, entonces dice que tenemos un terreno de estas dimensiones. Entonces, todo esto es el lado A, todo esto es el lado B y todo esto es el lado C. Correcto.
Sí.
Ya. Entonces nos piden hallar el área de todo esto. Entonces, para hallar el área de todo esto es muy complicado. Entonces, ¿qué se hace? Se lo divide en estas dos figuras. En un triángulo y un cuadrado. Diré, y un rectángulo.
Un rectángulo.
Ya, entonces, la unión de estos dos me va a ser esta forma. Entonces, y aquí tenemos C. ¿Esta altura cuánto va a valer? A menos C. Porque esto es C y esto es A. Solamente hasta aquí sería A menos C. Entonces, el lado de este triángulo es A menos C, ¿no? Todo esto es B, porque si esto es B, aquí arriba también es B. Okay. ¿Y este lado cuánto valdría?
A.
No, A es todo esto.
Menos C.
A menos B.
C. C, porque si esto es C, esto también es
C.
Entonces estos lados son C.
Sí.
Entonces, sabiendo eso, vamos a entrar de nuevo a programar.
C por B.
Listo, entonces aquí tenemos el ejercicio y aquí tenemos el código, ¿no? Entonces vamos a borrarlo, todo lo que hemos hecho. ¿Ya? Y vamos a empezar a programar. Entonces, ¿cuántas variables necesitamos? Necesitamos A, B y C. ¿No ve?
No,
Ok.
A, B.
Y C también.
Sí, porque
A, B y C.
Y vamos a poner que sea punto flotante. Y vamos a trabajar todavía con decimales. Porque, digamos, es base por altura sobre 2. Y a veces las divisiones no nos dan siempre números enteros. Así que vamos a mantener todavía los números decimales. Entonces esto va a ser, vamos a tener float A, float B, float C. Y vamos a tener dos áreas. Área, digamos, triángulo. Y área rectángulo. Y otra variable que sea área directamente. Que va a ser el área total. Vamos a poner área total.
Dime.
Perdón que te pregunte esto, pero no me acuerdo muy bien. Si hay, por ejemplo, 3 crestas, dividimos ¿qué por 2? ¿Qué dividimos
dos,
por
sí.
2? Entre 2.
La distancia. La distancia.
Oye, muchas gracias, mister.
Ya, de nada. Ajá. Claro, porque si era 3 crestas, 1, 2, 3, distancia entre la primera y la tercera es 12. Y ustedes saben que de cresta a cresta es wavelength, este es un wavelength y este es otro. Entonces tú sabes que si divides este 12 entre 2, ya tengo el wavelength. Y es lo que necesitan para hacer sus ejercicios. ¿Ya?
Sí. Mister, muchas gracias.
No, de nada. Si preguntan así, con gusto.
Nosotros vamos a utilizar ese máximo como un divisor para simplificar fracciones algebraicas. ¿Ok? Entonces, por ejemplo acá, cuando yo tengo que simplificar una fracción algebraica, tengo que ver, primero que nada, que exista una multiplicación, ¿sí? Acá hay un producto, ¿sí? Se nota que hay un producto. Y yo puedo simplificar entonces el 4 con el 4. Si acá por algún motivo, fuera x más 4 y no x por 4 o 4 por x, yo simplifico esto y ese es un error. Es un error, ¿por qué? ¿Alguien me puede decir por qué es un error? Chicas, solo chicas. ¿Alguna de las chicas, los chicos, alguna de las chicas me puede decir por qué es un error simplificar así? ¿O está bien?
No, es que el otro era división y no tendría sentido que sea suma, que lo sumes el 4.
Ese era
Bueno, no
multiplicación.
sé.
¿Ya? Ese era multiplicación. Cuando yo tengo fracciones, solo, por favor, eso no se les olvide. Solo puedo simplificar si hay un producto, ¿ok? Acá no hay un producto, hay una suma. Entonces, no puedo simplificar. Pero fíjense.
Okay, let's try some different exercises. Usted the camera, please. Okay, thank you. Okay, let's try a longer one, a longer exercise. Let me change the speaker view. This is the video. Okay, you can see the whiteboard right now. So let's try a longer one. Let's try to convert 100 miles per hour to meters per second. Miles per hour to meters per second. Am I recording? Yes. So I will have 100 miles over hour. Now this will be long, a little bit long. So check with your table. Everybody should have your table. You should have your tables. And let's try to see the conversion. I have the conversions here. Just wait. Don't tell me. I'm finding the conversions. Where is it? Where is it? Where is it? Where is it? Conversion factors table. Okay. So first you have to go from miles to meters. So if you have your tables, the only one that you have for miles is from miles to feet. So I can do that. 1 mile is 5,280 feet. With this, I cancel miles with miles, and I am right now with feet. But I have to reach meters. So let's find another conversion that has feet. I have a conversion that has from feet to, I have yards and feet, but I don't care about yards. It's better if I go from feet to inches. So let's convert that. 1 foot has 12 inches. With this, I cancel out feet and feet. Then I have inches, so I can go from inches to centimeters. So here I have 1 inch is 2.54 centimeters. With these inches and inches are gone. And finally, 1 meter has 100 centimeters. I cancel out centimeters and I have meters. This is one part of the conversion because I just converted the length part. But I didn't finish. I have to convert the time part from hours to seconds. So let's continue that here. Times, hour is here, it's down, so it has to go up. 1 hour has 60 minutes. So with these hours and hours, doesn't matter if they are far away, they cancel out. So I have minutes down. So I have to get rid of that minute. 1 minute has 60 seconds. Lo copié bajito porque no me alcanza. Minutes down with minutes up are gone, and I will have seconds down, which is what I want. Try to find all these. Don't forget, all the numbers on top will be multiplied, and all the numbers below will be dividing. So it will be this times this times this times this, divided by 100, divided by 60, divided by 60. Try that.
$44.704, Mr. Gonzalez.
Okay, that's what Valerie told me that. Also, Bricia, Fernando. Okay, let's see. Voy a hacerlo yo. 100 times 5280 times 12 times 2.54 divided by 100 divided by 60 divided by 60. 44.7, good. 44.7 meters over seconds. And we have converted that.
Okay, I will mute you all. Good, so today we'll do the new stuff. I will put the whiteboard so you can see what we're gonna do today. Okay, we're having this exercise. This is an example. A particle starts moving from a position of 8 meters. Then moves 6 meters to the left in 4 seconds. Stays there for 3 seconds. Then moves 6 meters to the left in 3 seconds again. Then it moves to a position of 5 meters in 2 seconds. Stays there for 5 seconds. And finally goes to the origin in 3 seconds. Draw the trajectory diagram, the position versus time graph, and the velocity versus time graph. These are all the questions. So I will start with the trajectory diagram. So for this, I will start with a little line here, and I will copy all my positions. 0, 1, 2, 3, 4, 5, 6, 7, 8. I don't know how long it will be. 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8. Good. Necesito ver quién faltó. Creo que están casi todos. Okay, so let's start. Voy a hacerlos participar, okay? Es facilito, de verdad, lo primero. Let's see. Paul, the first motion. It says a particle starts from a position of 8.
¿Lo hace?
Ahora sí estoy grabando.
Ah,
Okay. So I'm solving number 10, changing the information. So this will be angular velocity. Pulley 1 speeds at 25. Let's change it for 30. Instead of 25, 30. So you have angular velocity 1. And let's change the radius. We have all the information of the radius. Radius 1, it says 20 centimeters. Let's use 25 centimeters. And see, radius 2, 5 centimeters. Let's use 8 centimeters. Radius 3, it says 15 centimeters. Let's use 18 centimeters. Radius 4, it says 3 centimeters. Let's use 5 centimeters. Then N5 is number of teeth. Is 25. Let's use 20. And N6, it says 50. Let's use 45. Good. There you go. So this is a problem. I hope that you have copy. I'm recording. Don't worry. So let's go back to the whiteboard now. So I have the whiteboard right here. Good. You should be watching the screen right now. There you go. This is a problem. So we have a big pulley here connected with a transmission belt to pulley 2. Pulley 2 is on the same axis as pulley 3. Pulley 3 is connected with a transmission belt to pulley 4. Pulley 4 is connected to gear 5 with the same axis. And 5 is in contact with another gear, gear 6. You have angular velocity 1 is 30 radians per second. So with this, I need to find the angular velocity of gear 6. So let's convert all the radiuses. Is 0.25, 0.08 meters, 0.18 meters, and 0.05 meters. There you go. So now let's solve the problem. This is 0.08.
Okay, before I put the title, I want to show you something. You can see these two marbles here. These two marbles are completely addressed. There's something that I want to figure out, or you can tell me what is happening here. I will give motion to this marble so that it collides with the other one. What do you think the options? What do you think? Tell me 3 possible options that could happen here when I give a velocity to this. We have 3 options, or maybe more. I don't know. Who can tell me 3 options that could happen when I give motion to this marble and it collides with this? What do you think that could happen? Who can tell me the first option?
The other one
Could
will
push
move.
the second marble.
One by one. Vale, Vargas.
Oh, it could push the second marble.
Push the second marble, but what will happen to the first one? Will this continue moving forward? Will this stop? or will move backwards?
It will move backwards.
Stop.
Okay, so Vale says, well, this is marble 1, marble 2. It says that marble 2 goes to the right, but marble 1 stops. That's the first option, okay? Who has a second option?
Me. Morales.
Morales.
The second marble will go back a little bit at least.
This one? Go
No,
back?
sorry,
If
the
I
first
push
one.
this?
Sorry, the first one, the first one.
Okay, the first one, what happens to the first one? Goes back?
Yeah, it would go back when it bumps the second one with a little.
And marble 2?
We'll go forward.
We'll go forward, okay? Good. Is there a third option?
Stop. Yes, Medrano.
Medrano.
That both of them will keep on going forward.
Okay, 2 and 1 will go forward. Okay, these are the three options. I think that it's impossible that if I kick this marble 1, the 2 goes to the left. I think this is impossible in this situation. Okay, so these are the three possible options. So let's try. I don't know. Let's see what happens.
Okay, guys. Good morning. So let's start with the class. Let's make some examples, some other examples that you need to know. Let's try, for example, this. This is from your seminar. Let's try this one. Let's try this one. This is an equilateral triangle with size of 20 centimeters. 20 centimeters, 20 centimeters. You have one similar like this in your seminar. 20 centimeters, the charges are, I don't know, 7 microcoulombs, 12 microcoulombs, and 4 microcoulombs. The question is find the net force on the 4 microcoulombs charge on this. This is the problem. So we follow the same steps. We give it names, 1, 2, and 3. Then we mark the charge that we need to focus on, 4 microcoulombs, and we start drawing the forces that this charge is feeling. So because of this is feeling a repulsion. Over this imaginary line, this is feeling a repulsion like this. So this is the force that 2 exerts on 3, 2 on 3. It is a vector. Now from this, with negative, it feels an attraction. This is force 1 on 3. This is also a vector. So we have the two forces, 1 on 3 and 2 on 3. And we can find those forces. So force 1 on 3 will be the constant, 9 times 10 to the 9. The first charge is 12 times 10 to the negative 9. The second charge is 4. Sorry, times 10 to the negative 6. My bad, it's micro. Times 4 times 10 to the negative 6 divided by the distance between these two is 20 centimeters. It's 0.2. La Fer no está. Ahora Patiño, siempre me calculaba. Calculo yo. So this is 9 times 10 to the 9 times 12 times...
10.8, mister.
Recién.
No, ya esta vez que estaba muteada.
10.8. Good. 10.8 newtons. Don't forget to put the units. Then the force 2 on 3 is the constant, 9 times 10 to the 9. This charge 2 is 7 times 10 to the minus 6. This charge is 4 times 10 to the minus 6. And the distance is the same, it's 20 centimeters because it's an equilateral triangle. 0.2 square. So this is 9 times 10 to the 9, 7 times 10 to the minus 6.
6.3.
A ver, yo no confío mucho en Fer. 6.3, good. So far, so good. So we have